Welcome to Let's Get to the Marks. This is the AQA Chemistry 2023 Trilogy, that's Combined Science, Paper 1. This question's about carbon dioxide. Carbon dioxide is soluble in water, so forms an acidic solution. What ion does that? Well, that's the H plus ion. Remember the OH minus ion, which is known as the hydroxide ion, is what makes things alkaline. Okay, so the hydrogen ion or H plus ion makes things acidic, and the OH minus ion makes things alkaline. So when carbon dioxide goes in water, it causes the release of H+. Now name an indicator that can be used to test if a solution is acidic. Notice I used the highlighter, very important in your exams to highlight parts of the question. Well, we could use litmus paper, pH paper, or universal indicator. So just pick any one of those, and they all go red in color. Litmus paper goes blue to red. pH paper is normally an orange color. Universal indicator is a dark green color, and it's a solution which you use a dropping pipette with, but they all turn red in strong acids. Okay, that's yes. That's the end of question 1.2. We're moving on. Make sure you pause the video and have a go at the question before each one. Figure 1 shows the mass of carbon dioxide that will dissolve in 1 decimeter of water. So we've got mass of carbon dioxide on the left and temperature of water underneath. And you can see what's going on with the line there. 1.3, how does the solubility of carbon dioxide change as the temperature of the water increases? So as we go from 10 to 20 to 30 to 40 to 50 to 60, you can see the amount of CO2 is going down. Less carbon dioxide is dissolving, the hotter the water gets, or the more the temperature increases. Okay, so that will get you a mark. Now let's move on to 1.4. Make sure you pause the video and have a go before answering the question. 1.4, carbon dioxide dissolves in water to form an acidic solution. How does the pH of the solution change as the temperature of the water increases? Well, we know as the water got hotter, there was less carbon dioxide in the water, and that's acidic, so the water's going to get less acid. And if there's less acid in the water, because there's less CO2 in the water, how does that affect the pH? Well, the pH actually increases, because low pHs, pH 1 to 6, are acidic. And as you go higher, as the pH increases, you go to neutral, which is pH 7, then weakly alkaline, pH 8, and then right to the strongest alkaline or strongest base, pH 14. So as you get less hydrogen ions in the water, you go higher up towards pH 14. More hydrogen ions in the water, you're closer to pH 1. Calcium carbonate reacts with hydrochloric acid to produce carbon dioxide. The equation for the reaction is CaCO3 plus 2HCl goes to CaCl2 plus CO2 plus H2O. What's the symbol for the water? You all know that. Water's a liquid, so it has the symbol L. Don't mistake water as being AQ. Water can't be dissolved in water, so it's not aqueous. Now, what are these 4 bits of equipment? You've got a measuring cylinder, conical flask, and a weighing scale or a balance or a mass balance. And they want you to use these names in the next part of the question, which is a 6-mark experimental question. The student investigated the volume of carbon dioxide produced when different masses of calcium carbonate react with hydrochloric acid. Describe a method the student could use. So you want to use at least 5 different masses, so like 5 grams, 10 grams, 15, 20, 25 grams. How are you going to weigh them? Well, you're going to weigh them out on the mass balance. Make sure you zero the balance first. So you press the button that makes it go to 0 first. And then you weigh each of the masses. Now, you're going to want to use the measuring cylinder to measure out your hydrochloric acid. Now, when I'm in an exam, I like to give a number. So I'll say like, oh, measure out 20 centimeter cubed of hydrochloric acid. Or you could just say measure out the same volume of hydrochloric acid each time. But it's kind of cool if you give them the number. It makes it easier. So use a measuring cylinder to measure out like 20 centimeter cubed of hydrochloric acid, or you could just say the same volume of hydrochloric acid. Make sure the measuring cylinder is on a flat surface and you're wearing goggles because you're dealing with acid, which is corrosive. So the next step, once we've measured out our acid, is to pour the acid into a conical flask. Okay. Conical flasks are better than beakers because when the acid spits or bubbles, it's less likely to come out and be dangerous. Then add the calcium carbonate, the solid, quickly and stick the gas syringe in. Now you need to do that quickly so you don't lose any gas and you lose less gas and you get more accurate results. When it has stopped bubbling, you know the reaction's over. You can now look at your gas syringe and see what's the volume of gas released. And you can measure that. I would repeat it twice So for 5 grams, you want to do 3 lots of 5 grams, 3 lots of 10 grams, 3 lots of 15 grams, and basically take the mean amount of gas that was released or the average amount of gas released at each mass. And then you're going to want to um, plot that on a graph of massive calcium carbonate against gas released. And you should see that the more calcium carbonate, the greater the amount of gas released. And that will really get you your 6 marks for the experiment. I mean, there are things you want to keep the same called your control variables. You should probably mention that you can keep the temperature the same using a water bath. Make sure you use the same concentration of acid each time because acid concentration will affect the rate of reaction. Um, we already said keep the volume of acid the same each time. You should probably keep the surface area of the calcium carbonate the same. And you can do that by either using lumps or powder, but using the same shape of calcium carbonate. All right, let's move on. That's definitely getting you your 6 lovely jubbly marks. So, question 2. Lithium hydroxide reacts with sulfuric acid to produce lithium sulfate. The equation for the reaction is basically lithium hydroxide plus hydrosulfuric acid. Now, what that is you've got a base and you've got an acid, and they're going to make salt and water, lithium sulfate and water. What type of reaction is this? Well, when you mix an acid and base or acid and alkali, it's called neutralization. Now, calculate the relative formula mass of sulfuric acid, which has the formula H2SO4. So we want to do 2 times the H, that's 2 times 1. And then we want to do plus 32, because that's the sulfur. And then 4 times 16, because there's O4. And you add that all together, and you should get 98. And you get 1 mark for the working out, and 1 mark for the final answer. Perfecto. Let's move on. Okay, 2.3. Calculate the percentage by mass of oxygen in lithium sulfate, Li2SO4. The relative atomic mass of oxygen is 16, lithium sulfate's 110. Give your answer to 2 significant figures. So, once again, we're going to find out how much oxygen is in lithium sulfate. So you put the total amount of oxygen at the top, which is O4, and you put that over Li2SO4, and then you times 100. So you're going to do 4 times 16, which you're going to put at the top, and that's 64. So you're essentially doing 64 over 110 times 100. And this is going to get you 4 beautiful marks. So 64 divided by 110 times 100, excusez-moi, what's that, 58%? 58 point something percent. Now, we need to do it to 2 significant figures. So that's the first 2 numbers we want to round it to. And so as it's 58.18, we round it down to 58. Whereas if you look to the right, if it was 58.62, it would be closer to 59. So we would round it to 59. But in this situation, it's closer to 58. So we round it to 58. A solution of lithium sulfate contains zero point 0.3 grams of lithium sulfate in 25 centimeter cubed. Calculate the concentration of lithium sulfate in grams per decimeter cubed. Once again, bust out the highlighter, helps me with this. Now, there are 2 ways to do this. You can kind of do a mental maths way, or you can use the mass concentration and volume way, which is what I prefer. So in this one, you need to know that mass is equal to the concentration times the volume. You could do a little triangle. The only trick to remember that you always have to convert the volume into decimeters. Now our volume is our centimeter cubed over here. That's where I've put V. Our mass is where I've put M, 0.30 grams. So I want to do M over V. Now, you'll get 1 mark if you do 0.3 divided by 25, but that's not going to get you the 3 marks. So you need to do 0.3 divided by 25 divided by 1,000. So 0.3 over 0.025. And if you do that, you're going to get the answer, and that is 12 grams per decimeter. Now, there is a mental maths way of doing this as well. So the mental maths way of doing this is saying, well, they're asking me, they're telling me there's zero point 0.3 grams in 25 centimeters. And then it's asking me how many grams in a decimeter, like GDM3. So how many grams in a decimeter? A decimeter is 1,000 centimeters. So if there's zero point 0.3 grams in 25, how many are in 1,000? Well, to work that out, you could do 1,000 divided by 25 times zero point 0.3. That's just one of the ways you can work that out. And if you do that, you will find the answer is also 12. So some people might be more comfortable with that. Personally, I'd use the triangle, works every time, but some people prefer the kind of mental maths way of doing it. There we go. Let's roll. Question 3. Sodium in group 1 of the periodic table. Sodium reacts with oxygen to produce sodium oxide. Balance the old equation. Over here, we've only got one oxygen, but we've got two on the left. So immediately, like, we've got two NAs and just one O. And over here, I've got two O's. So immediately, I'm going to have to put a 2 there. And once you put a 2 there, it means there's 4 NAs. So I've got to go to the other side and put 4 for Na. Right, let's do 3.2, 4 marks. Explain what happens to the sodium atoms and the oxygen atoms when sodium reacts with oxygen to produce sodium oxide. Answer in terms of electrons. Now, these are very common in AQA to explain what happens when you form an ionic bond. Okay, so what we want to say is where the electrons have come from and who they're going to. So the electrons go from sodium to oxygen, basically, and that would get you a mark if you just wrote that. But each sodium gives one electron, because there's two sodiums and one oxygen. Each sodium gives one electron to oxygen, so oxygen gains two. This is going to have got you 2 or 3 marks, just explaining in terms of electrons what's going on. Now, I would also write they now have, sodium is now a positive ion and oxygen is now a negative ion. You could put the charges. Sodium is +1, oxygen is -2. But I'd also add they now have full outer shells of electrons. And you could say they've also formed an ionic bond. It's always worth putting a little bit of extra to ensure that you've got the 5 marks, unless a question says specifically only write 2 answers, like here. It says give 2 observations, so don't give 3. I'm going to give you 3, but only give 2 observations in this question. What would happen if you burnt sodium in oxygen? Well, sodium burns with a yellow flame. But also, so you're going to see a flame or a light or a bright light. You could say I'm going to see sodium glow, but you're going to also feel heat. It's going to get hot and you're going to feel that heat coming off. That is an observation as well. Now, notice I've written 3 things. You would only give 2. Otherwise, in the exam, if you write something that's incorrect, they'll cross out one of your correct answers as well. So always, if they say, like here, describe 2 differences, only state 2 differences. If you write 3 and 1 is wrong, you're only going to get 1 mark. Okay? So purple flame is what you'd see with potassium, but also it would give off more heat as it would get even hotter. Um, the reaction would also finish more quickly or faster. So we're now on to question 4.1. Group 7 elements known as halogens. All of the atoms of group 7 elements contain protons, neutrons, and electrons. What's the order of discovery of the proton, neutron, and electron? Well, the electron was definitely discovered first, so it's got to be one of these two. And it was discovered by a guy called J.J. Thomson, who came up with the plum pudding model. And then the proton was discovered, and then the neutron by James Chadwick. Okay, let's move on to 4.2. So, table 1 shows the mass of a proton and an electron. A proton is 1.673 times 10 to the minus 27. An electron is even lighter, 9.109 times 10 to the minus 31. So, how many times heavier is the proton than an electron? Just divide the mass of the proton by the electron. Just write into your calculator 1.673, then press the times 10 button. You'll find that at the bottom, and then write minus 27. Then press divide, then 9.109, press the times 10 button, then write minus 31. And then press equals. And you'll get your answer for 2 marks. So this is really about testing you. Can you use the times 10 button on your calculator? And the answer is 1,836 times. The proton is 1,836 times heavier than the electron. Okay. A bromine atom can be represented as Br with 81 at the top and 35 at the bottom. What is the number of neutrons in a bromine atom? So first of all, we need to remember what those numbers mean. Well, the mass number, which is the big number, that is the protons plus neutrons. And the atomic number at the bottom is just P, just protons. So to find neutrons, N, we need to do 81 minus 35. So you're kind of doing P plus N minus P equals N. And that will tell us that there are 46, 46 neutrons in this bromine atom. So 4.4 is asking what number of electrons are in a bromide ion? Well, protons and electrons are equal, so you might think it's 35, right? But a bromide ion is not a bromine atom. It has an extra electron because Br forms Br minus. So there's actually 36 electrons in a bromide ion. Right, 4.5. Chlorine has two isotopes, shows the percentage of abundance and isotopes in this table. So chlorine 35 exists as 75.77. Chlorine 37 exists as 24.23. Is its abundance. So we need to do the mass of each isotope times the abundance. You can forget the proton number. You don't need that here. It's just to throw you off. So you do 35 times 75.77. Then you do 37 for chlorine 37's mass times 24.23, which is abundance. Make sure you put brackets, otherwise this will come out wrong in your calculator. And divide by the total abundance, which normally is 100%. And you should be getting a number between 35 and 37. If you get a number over 37 or below 35, you've definitely gone pear-shaped. So this will get us 2 of the marks when we come up with the answer. But remember that it's to 2 decimal places. That means after the dot, you need to have 2 decimals. So it's 35, and we've got 4.48. And that is our answer. 35, and then 2 numbers after the decimal. Awesome. Okay, so now we're looking at covalent bonding, which is all about sharing. 4.6 shows the outer shells in one molecule of chlorine. Complete the dot and cross diagram to show the electrons in the outer shells. So when you're doing covalent bonding like this, where the orbitals overlap or the shells overlap, you have to just know the group number. You don't need to draw any of the inner shells. So you don't really need to look at the number of electrons, which is the proton number, the atomic number. So chlorine's in group 7, so I know there's going to be 7 circles in one and 7 crosses in the other. In order for them to get 8, they need to share 1 each. Now you can draw those on the line like that, with the dot and the cross in the middle on the line, or some teachers prefer you to draw the cross and the circle within the space between the 2 lines, as I have now. Both of them would get you the 2 marks, okay? So super. You're wondering why it's 2 marks. 1 mark for the number of electrons in the outer shell and 1 for showing the correct amount being shared. Right, why does solid sodium chloride not conduct electricity? Why does a solid ionic compound not conduct? And the answer is the ions are not free to move. They're locked into place in a giant lattice. So you can just put the ions are not free to move. And this is why current can't flow. But the marks here is just for saying the ions cannot move. Right, 5.2, sodium chloride solution, AQ, conducts electricity. How else can you make sodium chloride conduct electricity? Well, you can melt it, and we say it is molten. Okay, MOLTEN, bit of a fancy word for melted. Figure 5 shows the apparatus for electrolysis of sodium chloride solution. So we've got a power supply, some wires, we've got a positive electrode, negative electrode into the electrolyte. Suggest an element that you could make the inner electrodes out of. Well, electrodes are made of graphite normally, and the element is carbon. Platinum is another possible element you can make electrodes out of, but the answer they're really looking for here is carbon. Complete the half equation for the production of chlorine at the positive electrode. This is the most common one in all AQA exams, so if you don't understand how to do these, learn this one off by heart. 2Cl minus goes to Cl2 plus 2E minus. It's the most common half equation to be asked ever in AQA GCSE chemistry exams. Remember, halogens are diatomic, just like H, N, and O. Have no fear of ice cold beer is a mnemonic you can do to remember all the diatomic molecules. Sodium chloride solution has a pH of 7. During electrolysis of sodium chloride solution, hydrogen gas is produced. So that's going to get you 2 marks because they've broken this 4-mark question into 2 parts. The pH of the solution increases. Explain why. So really you're going to get 2 marks for explaining why hydrogen gas is produced and 2 marks about the pH. So hydrogen ions are positive and they're attracted to the negative electrode. So that's going to get you a mark. Then we can say what happens to them. Well, they pick up electrons because they're H plus. So there's going to be H plus E minus goes to H, although that's not balanced. So there's a little half equation there. They're gaining those electrons. If you wrote the half equation, you get the 2 marks for this anyway. So hydrogen ions gain electrons, they are reduced. That would get you both marks. We can also say, why does hydrogen come off and not sodium? Because it's sodium chloride solution. So there's two positive ions in there. Well, hydrogen is less reactive than sodium, and it's the less reactive positive ion that comes off in a solution. So if there's a more reactive metal than hydrogen, hydrogen will always come off. The only time hydrogen doesn't come off in a solution is if you have copper or silver or a less reactive metal than hydrogen. Right, why does the pH increase? Why does it go up? I.e. go up from 1 towards 14. So pH is a measure of the hydrogen ion concentration. It's actually the log of the hydrogen ion concentration. So pH 1 is 0.1 mole per decimeter. pH 2 is 0.01 mole per decimeter. So as the hydrogen escapes from the solution, there are less hydrogen ions in the solution, so the pH increases. And this is because pH is a measure of how many hydrogen ions are in the solution. pH 1 has a concentration of 0.1, pH 2, 0.01, pH 3, 0.001. So you see, with each increase in pH, you have 10 times less hydrogen ions. So pH 3 has 100 times less hydrogen ions than pH 1. So that's why, as the hydrogen ions escape, we have less left in the solution. And there's your 4 marks. Of course, you didn't need to write all of that. You could have probably just said pH is a measure of hydrogen ions and hydrogen escapes, so there's less pH. Less hydrogen ions. Right. 6. Acids react with some metals to produce soluble salts. The equation for this reaction, Mg plus 2HCl goes to MgCl2 plus H2. Describe how the solid magnesium chloride is obtained from the reaction mixture. So remember, it tells us that the magnesium is in excess. So when this reaction is done, all the acid is used up, and we've got silver metal magnesium floating in a magnesium chloride solution. So we need to first of all filter out the silver magnesium metal, so filter off excess magnesium, and then we should evaporate the water, the AQ bit of MgCl2. Remember, when you see AQ, it means the thing before it is dissolved in H2O. So we need to evaporate the H2O or crystallize it to get the MgCl2, and that will get you the 2 marks. The reaction between magnesium and hydrochloric acid is a redox reaction. What does redox mean? Well, it's an abbreviation or a shortening or whatever they call it for reduction and oxidation. So you've got 2 reactions happening here. Something's being reduced, something's being oxidized. You might remember the oil rig, which helps you remember oxidation is loss of electrons and reduction is gain of electrons. I've written gain there, you idiot. So yeah, I shouldn't have written gain there. That should be oxidation is loss of electrons, hence the OIL, and RIG, reduction, is gain of electrons. So all you've got to do here is work out, is the magnesium being oxidized or reduced? It's either gaining electrons or losing electrons. So you could kind of do a 50-50 here if you can't remember it. But we can work it out, and I'll show you how. Atoms always have 0 electric charge. So magnesium is an element or an atom in its elemental form. So it has 0 electric charge. It's the same amount of protons as neutrons, so it's neutrally charged. However, when magnesium forms an ionic compound, i.e. magnesium chloride, when it reacts with something, it's either going to gain or lose electrons. And it's a metal, so it's always going to lose electrons. Metals always lose electrons. And magnesium's in group 2, so it loses 2. Oxidation is loss, so we know that magnesium has lost electrons. It has been oxidized, and those are your 2 marks. Magnesium loses electrons. It is oxidized. Superbolus. In this situation, it's the hydrogen that's actually reduced, but the question doesn't ask you that. The hydrogen picks up electrons to become a hydrogen molecule. Right, here we got some maths. 6.3, 0.72 grams of magnesium added to 100 centimeter cubed of hydrochloric acid. The hydrochloric acid is in excess, meaning there's more hydrochloric acid than magnesium. Calculate the concentration of magnesium chloride solution produced in grams per decimeter cubed. Now, anytime you've been given grams, which is a mass, and you've been given the AR or the MR, we've been given the AR and MR of magnesium and magnesium chloride, we need to work out moles. So I'm going to write the equation out, and equations are brilliant because this was already earlier in the question. You didn't have to write this out here. It was earlier in the question. But this gives me a ratio, which I'm going to come on to. So I'm going to take the mass of the magnesium, and the first thing I can do is work out how many moles of magnesium I've got. So I'm going to do 0.72 grams, and I'm going to divide that by 24, which is the AR of magnesium. Remember, mass over MR equals moles. I use an N for moles. You should do too. It means number of moles. So I have 0.03 moles of magnesium, first mark out of 6. Boom. Now I need to look at the equation and see what is the relationship between magnesium and magnesium chloride in terms of ratio. Well, it's a 1-to-1. Notice there's no numbers in front of magnesium, no numbers in front of magnesium chloride. So it's a 1-to-1 ratio. So if I have 0.03 N or moles of magnesium, I've also got 0.03 N of magnesium chloride. That's your second mark because you worked out it's a 1-to-1 ratio, maybe even your third mark for saying 0.03 N. Now I need to turn this into mass because we want our answer in grams per decimeter for magnesium chloride. So I'm going to do moles, which is 0.03, times the mass or MR of magnesium chloride, which is 95. And it tells us that in the question, the 95. So 0.03 times 95 gives me 2.85 grams of magnesium chloride. So I have just smashed at least another mark, possibly another 2. We're on to like 5 or 4 out of 6. Now I just need to work out the concentration. So I'm going to draw another triangle. This is the second mole one you need to know for combined science or trilogy. It's mass over concentration times volume. So I've got the mass is 2.85. I need to just find the volume in the question and divide it. But there's one more element. Volume must always be in dm cubed. So dm to the 3. They always give it to you. I've circled here and written a V. They always give you it in centimeters. So you'll always need to divide the centimeters by 1,000 to get into decimeters when you're doing mole calculations. So that equals 0.1 dm. So I'm doing 2.85 divided by 0.1 and I get 28.5. And that's the answer. Grams per decimeter, 6 marks. Boom. Question 7. This question is about the structure and properties. Which pair of substances both contain carbon atoms and hexagonal rings? Well, if we look at diamond, diamond does not contain hexagons. It has, I'm sure you're all familiar roughly with the picture of diamond, my GCSE D art. And silica is exactly like diamond, except for it has white circles and black circles because it's made of silicon and oxygen, rather than just diamond is made of carbon. So it's definitely the middle one. Fullerenes and graphene both contain hexagonal rings of carbon atoms. Right, 7.2, explain the structure of copper atoms. Basically, why depending on its structure, why does copper conduct heat? Well, the copper atoms are in a solid. So just describe a solid. The particles are close together, arranged in layers, regular structure. You get the idea. The structure is regular, atoms next to each other. When they heat up, they gain kinetic energy, vibrate, and pass that energy on to the molecule, the atom next to them, sorry, or the metal ion next to them, because they collide, they move more. Now, we should also add that metals contain delocalized electrons, which increase the number of collisions and therefore further aid with the transfer of heat between the particles. And that's why metals are the best conductors out of all the solids. Okay, zing, zing, zing. 7.3, explain why copper oxide has a high melting point. Well, copper oxide is ionic, okay? And so it's going to have a giant ionic structure. Now, any single time they ask you in chemistry, why does something have a high melting point? It has a giant structure. So that's your first mark. You'll always get that mark. Okay. Just say the word giant. If they say something has a high melting point, giant gets you the mark. So giant ionic lattice. So even if I mess it up and call it giant covalent or giant metallic, I'll still get a mark for the word giant. So it's a giant structure. And every giant structure has lots of strong bonds. In this case, they're ionic bonds. You should give the description of an ionic bond. It's a force of attraction between oppositely charged ions. I've put it in brackets here, but really you should say that. But if you can't remember that, just say lots of strong ionic bonds. And then if there's lots of strong bonds, they're going to need lots of energy to break. So even if you don't know if something is ionic, covalent, or metallic, if you just say something has a giant structure, needs lots of energy to break, lots of strong bonds, you'll get most of the marks. You'll get 3 out of 4 or 2 out of 3. You'll get most of the marks. You'll only gain that full mark for stating the type of bond, i.e. is it covalent, is it ionic, is it metallic? But just remember the others. Giant, lots of strong bonds, lots of energy needed to break. Now, simple molecules over here, like water, they have low melting points. So anytime they ask you, why does this have a low melting point? Why is this a gas? Why is this a liquid at room temperature? All of that is the same answer. It means it's a simple covalent molecule. Now, covalent molecules have very, very strong bonds. Don't use the word bonds in this answer. Just say it is a simple structure or a small structure. It has weak forces between the molecules. If you want to shorten that down, you can say it has weak intermolecular forces. And then we say do not need a lot of energy to break, or only needs a little bit of energy to break the forces, okay, or overcome the forces. So with simple molecules with low boiling points and melting points, you are breaking forces, not bonds. You're breaking intermolecular or forces between the molecules. Okay, and they are simple structures, and that is the end of the test. So please share, like, subscribe, check out all my other walkthroughs for AQA Combined Science. Let's go, let's get to the marks.
You're still here? It's over.